How you doing? Mr. D here. So welcome to 1.1 practice. We're looking at limits to start off this unit. And we're going to look at all things limits graphically. So on number 1 here, we're using this graph right here. And so the first one, I'm going to go across the first row here. It's asking for the limit as x to the negative. That means as it's approaching from the negative side. So let's look at this graph where x is equal to 1, which is right here. And as it approaches from the negative side, it's approaching this value. Even though it's not equal to negative 1, it's approaching negative 1. So that's negative 1. Okay? And then the next one is f of 1. So that means just find the function value. Okay? So the function value is actually positive 1. That's the value of the function. And then the next one is finding when x approaches 0. So it has to match from both sides. And so I go on my graph. When x is 0, I'm on the y-axis. And the function approaches to both sides. It's a continuous in that area. It actually goes through 0. So that's actually the function value. It actually approaches 0 and is equal to 0 there. So the limit is 0. So then the second row, I'm looking at when x approaches 2 from the positive side. So let's go over to where x is equal to 2. That's up and down here. And from the positive side, I'm going to the left, and it's approaching that open circle, which is a value of 1. The next one, they're trying to find f of negative 1. That's the function value at negative 1. So when I go to negative 1, I've got an open circle and a closed circle. It's the closed circle, right? Which is equal to positive 1. The next one's, what's f of 2? Again, function value. So f of 2, so when I go over here, ooh, there is no function value, is there? I got an open circle, and there's nothing there. So I'm going to write undefined. Okay. And then the next row, the final row for this graph, what happens when x approaches 1 from the positive side? Here's when x approaches 1 from the positive side. Or x is equal to 1. Does it approach from the positive? Well, you get this little piece over here, but it stops. So actually, there's nothing approaching 1 from the positive side. So that's why you have to write does not exist. There is no limit approaching from that side. Okay. And then the next one, as it approaches 1 from the negative side, that approaches from the negative side. It approaches the open circle, which is negative 1. And then lastly, when they have it just equal to a positive 2, that means from both sides when they don't specify. When x is 2, I've got it right here. Well, it only approaches from the right. It doesn't approach from the left, so that does not exist. It only has a right-sided limit for that one. Okay, so number 2, we're talking about this bad boy right here. Okay, so the top row. When x approaches 3, where's 3? Right here. It goes right through this negative 1 value. So it approaches from both sides, negative 1. And then they want the function value for 1. So when I go over to 1, oh, undefined. And then what's the limit when it approaches 1? Well, it's not defined at 1, but it approaches from both sides. It approaches that y value of negative 5. And then next row, what happens when we approach 2 from the positive side? Here's x equals to 2. From the positive side, it approaches, and it's equal to the negative 3. Okay. What's f of 3? So go over to the f of 3, and it's equal to negative 1. And then What happens when we approach 2 from the negative side? Here's f of 2. Same thing as when it's from the positive side. It's equal to -3, isn't it? And then, therefore, oh, no, that's -2. So the limit as we approach -2, well, here's -2 right here. And those do not agree, okay? It approaches +1 from the left, and it approaches +4 from the right. And then it's defined as something else, but that's irrelevant for this one. It's just they don't match, so that's DNE. Okay, it's not because it's undefined or anything. It's they don't match the limits. So then f of -2 is actually what that value is, that closed circle right there, which is +3. And then lastly on this one, f of 4 is equal to +1. So it's that coordinate right there. Okay, so the number 3, we get this other crazy looking graph. So what happens when we approach 3 from the positive side? 1, 2, 3, it's approaching the 1 value. Okay. What is f of 3? F of 3 is, I got to erase that. I did some writing on there. F of 3 is not defined. It's open circles for both those points. What's the limit as we approach 0? Well, it's not what it's defined as. From both sides, it approaches the 1 value. Even though it's open circle at 1, it approaches at both of those. Okay, and then the next row, what happens when we approach 3? Again, those don't match. Here's 3, it goes to 1 here, and -2 here does not exist. And then f of 0 is the 2 value. The limit when approach 3 from the negative side, that's approaching this way, so it's equal to -2, where that open circle is. And then the limit as we approach 0, let me erase this stuff. When we approach 0 from the positive side, so when we approach, well, it's going to be the same as the negative side, but positive side, it approaches that open circle, and it's equal to 1. Okay? The next one wants me to find the function value for 1. That's just, that's actually just equal to, let me erase that, 0, right? 1, 0. And then f of -1.6, that would be right about right there. So that looks like just -1. Right there. Okay. And then number 4, what's the limit when x approaches 1 from the negative side? When it approaches 1 from the negative side, it zooms right into the 1. What's f of 2? F of 2 gives me that point right there, which is also 1. What happens when we approach 2? From both sides, this side and this side, it approaches the 4. Okay. And then what's the limit as we go to -1? It approaches from both directions. It approaches the 1. Okay, I'm going to erase this mess. And then they want me to find f of 4. So f of 4 is undefined because there's an open circle there. The limit when x approaches 1 from the positive side is approaching this open circle, which is a y value of 4. The limit when it approaches -1 from the positive side, that's approaching this point right here, which is also 1. And then what's f of 1? It's that point right there, which is 1. And then what's the limit when x approaches 4? From both sides, it's approaching that open circle right there, which has a y value of 2. Okay? So next up, Got one more of those on number 5. Got one more graph. So I want the limit as x approaches 3 from the negative side. That's approaching this, which is 4. F of -1 is, that's an open circle, so it's undefined. The limit when we approach -3. Here's my -3. It's not what the function value is. It's this right here that it approaches from both sides, which is a y coordinate of 4. Okay. And then, let me see. Next row, when we approach -1, it's equal to that negative circle value of 2. Again, I'm going to clean this up. When I get to f of -3, that's this value right here. That's a function value, which is 1. And then the limit when it approaches 3 from the positive, that's down here. Way down here, it's approaching from that side. That's equal to -2. F of 3 is the closed circle, so that's different. That's equal to a 4. When x approaches 0 from both sides, it's equal to 3. And then lastly, find the function f of -4. -4 is right here. That looks like that comes out to be 3. And that's it. Okay? So then the next problems are kind of fun. It's like all our answers may look a little bit different, but they're kind of hard to grade because your graph might not look exactly like mine, but they got to meet certain requirements. What I do is I tick down through the ABC and I plot any actual function values and I get those laid out. So for example, on A, I know that -2 is equal to 5. So I'm just going to plot that 1 point, -2, 5. I have to have that. And that gives me some parameters. Okay. And then that's all they give me for points. So then it's just a matter of kind of, you just don't want to draw too much too quickly. So the next one says when I approach 2, okay, it's equal to 1. So basically I'm going to have 2, 1. It could be an open circle or closed circle right there. And it's going to connect to that open circle, but I'm not going to draw anything yet because there might be some other stuff going on. Okay. So then the limit as we approach 4 from the positive side is 3. So I'm going to have a point, again, it could be an open circle, 4, 3, like this. And it's going to approach from the positive side at some point. Now, I could draw something like this, but sometimes they tell you if it's increasing or decreasing, so I'm kind of waiting. But I'll do that. I'll just draw. I might have to modify that. I could have just as easily done this. I know it's going to the right. Okay? And then now they tell me f is increasing from anywhere less than -2. So notice I had the -2 thing right there. So I'm just going to draw a piece of graph going off of that like this. That way it's increasing as it approaches that. Okay? And then lastly, the limit as x approaches 4 from the negative side is less than from the positive side. Okay? So I'm going to make another point below that one and have it connect off of it and then touch that open circle. And then I might just do this. I might just draw it. It doesn't have to do this, but I might do something like that. And then I'm just going to do this. And again, it didn't have to be increasing that way, but that meets all the requirements. Okay? Number 7. I've got 1, 3, when g of 1 is equal to 3. So I'm going to knock that off right off the bat. Okay? Now again, I might not have any graph ever going through any of that. It depends on what the other stuff tells me. But I know I have that 1 point there. Okay, so the limit when we approach 1 is actually equal to -2. So I'm actually, when I approach 1, I get -2 from both sides. So I'm going to have an open circle, and I'm going to end up having a graph connecting into that from both sides. But again, I'm going to wait. I'm going to wait and see if it tells me anything else. Then they tell me that the limit when you go to 3 from the positive side is equal to 5. So I'm going to plot 3, 5 with an open circle. And from the positive side, it connects into that. So I might do that. Again, I might adjust it, but I don't want to lose track of the fact that it connects into that. Okay. Then they tell me f is increasing from -5 to -3. So from -5 to -3. So I'm going to make it do this and this. So it's increasing all the way through. Okay. And then they tell me that the limit when you approach 3 from the negative side is bigger than when you do from the positive side. Oh, so I'm going to have to redo this right here. And where these connect, they're not going to connect up. So it's going to be increasing. And that's from the positive side. Is that positive side bigger? No, it's smaller. So when it approaches from the negative side, I might do something like this. It comes in higher, and it's still increasing. So it looks something like that. And let's see. That might look a little weird to have an open circle there. Didn't I say I had to have a limit there of -2? So, that is interesting. So I have to have a limit that's equal to -2. So I have to have a graph going through there and continuing on. And then I have to have it going from the limit of 3 from the positive side is smaller than from the negative side. So this is tricky to draw because I'm going to make that a little bit smaller. Because it had to equal 5. So I've got the 3, 5. I'm going to draw that really, really small. And then I need the limit from the negative side to be higher. Okay? And it's still got to be increasing. And so I could do something like this. Like that. So that was tricky. Okay? So, number 8, sketch that graph, okay? It's funny, every time I have my paper and every time it can look very different, but it's got to meet all the criteria. So scanning down through there, h of 3 is undefined, okay? So I might want to put just a dotted line just to help be a barrier, make sure I don't draw any lines through that. H is constant from -2 to 3. I don't know where, but it's going to be a horizontal line. So from -2 to 3, but it can't be defined there. So open circle, okay? I might need to raise that or lower that based on some of the other parameters. So h is a constant. So I did D. The limit as x approaches 3 is the same as h of -2, which is 1. So I've got the point negative 2, 1. Negative 2, 1, right there. Okay? And the limit as x approaches 3 is equal to that. Oh, so what I'm going to have to do is move that horizontal line because I need the limit as it approaches 3 to equal this. So what I'm going to do is I'm going to move this down, like I said. I knew it was horizontal, but I knew I might have to move it. I just put it there to start. So now now what I've done is I've got the constant. It's still undefined at 3, but the limit as we approach it is the same as right here, that point right there. Okay? And then the last thing we got to do is the limit as we approach negative 2 from the negative side is smaller than from the positive side. So where's negative 2? Right here. So this is approaching from the positive side. So I just got to make where it comes in from the left to be lower than that. Okay, so I might just do something like this. And then I'm good. Okay, I could have just as easily done this. Or squiggly. I just need it to come in underneath the other one. That's why they can kind of look different. Okay, and that's it. So, some test prep. These are like some AP style problems that we got to do. So the graph of this function f is shown. Which of the following statements is true? This says the limit as you approach a is the same thing as when we approach b. When I approach a, I get this, 4. When I approach b, it's undefined. That doesn't work. Okay? Sometimes you just go down the list and approach it. The next one, the limit as you approach a of f of x is 4. That actually is true. I don't think I need to eliminate any of the other ones. I don't need to waste my time. Okay? So which ones of these are true? The limit as x approaches 2 from the negative exists. Yes, it does, doesn't it? Approaches 2 from the negative, it's equal to something. We don't even know. But I'm going to write true for that. Number 2 says the limit as you approach 2 from the positive side exists. Yes, it does. It's equal to that value. True. The limit as it approaches 2 exists. For that to happen, they have to match up. That is false. Okay? So I'm looking for 1 and 2 only, which is C. Okay? Number 3. This one's tricky. You got to know what step function is. Step function, greatest integer, means you round down for any value I put in there. So if I plug in f of 1.1, that rounds down to 1. But if I put in 1.9, that runs down to 1 also. So when you graph a step function, everything from 0 to 1 is equal to 0. So you get a horizontal line until you get to 1. And then when you get to 1, it's equal to 1. 1 runs down to 1. And then everything from 1 to 2 is equal to 1. So you get that step right there. And so forth. Okay? So